Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps in the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so our first question. There are 1,000 grams in a kilogram. So we're going to divide through by 1,000. So that's in 3 places. And our answer is 7.8. Okay, right, 0.07 is a percentage. Now, to write a decimal as a percentage, it's useful to see it as a fraction first. So we've got units, tens, and hundreds. 7 is in the hundreds column, and percentage means out of 100. So we've got it straight away, and it's 7%. Okay, so to do 2 decimal places, we go to the point and we count 2 places. So I'm going to be cutting the number here. I box this one. If it's 5 or more, then I add 1. It is 5 or more, it's 6, so it becomes 7.84 as a final answer. This question, -5 or -5 squared, means this. 5 times 5 is 25. And 2 negatives make a positive, so it's 25 as a final answer. Okay, write down all the numbers in set A. That is all the numbers in the A circle. Write down the numbers that are in the set A, and then you've got this symbol. Now, when I see this symbol, I see it as an N for and. So it's in the set that's A and B. And that is our crossing over section. 3 and 8 are in A and they're in B. Okay, 23 is the smallest 2-digit number that we can make with those 4 digits given. For the 3-digit question, we want to get closest to 300. Now, we can't just assume the first thing we see is correct. So I could make 324. Now, that is
24 over. So I'm 24 away. And then I've got 283. That is 17 away from 300. So 283 would be the correct answer. And it's a 2-mark question. So they're expecting to see some sort of working out going on over here, not just a single answer. So we've got to put 1 digit in each box to make the largest possible total. So 9 going with a smaller one, and 7, the next biggest, going with the other smaller one, is going to help me create that biggest total. Add those together and you get 166. You could equally have written 75 and 91. Both would have worked. Okay, the coordinates of A. We go along the corridor, up the stairs. So the 4 is first, and then it's the 2. So using that same principle along the corridor to -3, and then it's not got a number. We're not going up or down. We're literally staying right there. So we've got to complete the diagram for pattern number 4. So it's really important to take your time, have a good look at what's happening. This was our original pattern, and I can see when I look at pattern 2 that the original pattern is here, which means this is what's getting added each time. So that's what I'm going to put on to the end. So there's the 3 and the 1 jutting out. I've got to complete the table. I can go back and count the tiles or the squares, or I can just look at what's happening here. I can see it's going up 4 every time. So I can just add 4 each time to get there. I've then got to find the number of squares used for pattern number 10. I'm at pattern number 5 at the moment. So what I could do is just keep the table going. 5 was 21. I want to go 6, 7, 8, 9, 10. So that's how many I need to do. And I just keep adding my 4 each time. And that's probably the easiest way to do that question. Okay, so 2 numbers are added together and the answer is 15. Both these numbers are factors of 24. So the first thing I want to do is get those factors of 24. So those are all the numbers that multiply to make 24. I write them as pairs so I don't miss any off. It's really the best way. And now I've just got to look at those numbers and find which ones I can put together to make 15. And that would be the 12 with the 3. Okay, now for this question, I'm not going to be able to demonstrate this perfectly, which is a shame. I'm just limited a little bit by the software. But what I am going to do is talk you through the 2 different ways that you could approach this. If you're going to make an accurate drawing of an equilateral triangle of side length, the first step in either method would be to use your ruler and accurately measure out 5 centimeters and label it on so that it's really clear to the examiner you know what you're doing. Now, in the first method, I'm just going to use a compass. I am going to put the tips of the compass onto my ruler so that I can measure out 5 centimeters. So the gap between the point and the pencil is exactly 5. I would then stab my compass on the end, and very carefully I would put an arc onto my page. I would then move the point to the other end, and what's critical here is no movement happens on the arms of that compass during this whole process. And when I do my other arc, they will cross. If they don't cross, something has gone wrong, some sort of movement has taken place. The crossing point is where both parts are exactly 5 centimeters. And so you would draw up to that crossing point with a nice straight edge using your ruler, and all your edges will be 5. Obviously, mine doesn't look perfect. Mine's a sketch just talking you through it. But there isn't another way of doing this. So that's one way. If you're not very good with a compass, then there's a way of doing it with a protractor. Because it's an equilateral triangle, it means that all the angles inside are 60 degrees. So what I could do is I could place my protractor. So let's give you an image of a protractor quickly. You've got that crossing point here in the middle, and that's what I would be putting on the end of my line. I would then measure my 60 degrees and I would mark it on, and then I would just draw a nice long straight line through that point. I don't know how, well, I could draw it exactly 5 centimeters. I do know how long I need it, but I don't need to, because what's going to happen is I'm going to measure my 60-degree angle on this side, and when I come through, it will automatically create my triangle. It'll look a bit like a wigwam. Don't rub that out, and don't rub these out either. These are your construction lines. It shows the examiner what you have done to get your perfect triangle. All right, so those are two possible ways that you could go about that. Okay, so to work out which of these has the biggest calculation, we basically need to do them, and they're testing our knowledge on the word sum, difference, and product in this question. So the sum is when you add. So we've got 14 and 19, which is going to give us 33. The difference between is a takeaway. So we've got 57 take away 29. So here we would have to take one, carry it across, and then that gives us 8, that gives us 2. So at the moment, our sum is giving us the greatest. Product means times, and 9 times 4 is equal to 36. Now that is the biggest, so that's the one that we will choose. Okay, so we've got a park and ride timetable. Sadia gets to the car park at 7:45. And she catches the next bus in. What time does she get into the town centre? Now, if it's 7:45, she's just missed this one, which means she's going to be getting on the 8 o'clock. So she's going to arrive at 08, 12. Okay, so we've got the bus timetable from the town centre to the car park, and we need to work out how many buses go between 8 and 10. So we've got 1, 2, 3, 4, and then every 15 minutes. So we're just going to write our 9:20, add on 15 minutes, and that takes us to 9:35. Add on 15, and that takes us to 9:50. If I add another 15, I'll be over 10 o'clock. So there's 3 more buses. Sorry. So there are 2 more buses. Remember, we've already counted the 9:20 in our count up here. So in total, there are 6. So Paul wants to leave the town centre at 7:30. He's going to catch a bus to the car park. What is the time of the first bus Paul can catch after 7:30? So the timetable is telling us here that it's every 15 minutes until 20 past 7. So our time is running in this section here. Now look at what we've already worked on. We've got that 9:20, 9:35, and 9:50. If we added the next time, it would have been 10:05. And then the next time after this would be 10:20. So we'll have done a full cycle. There are 4 15s in an hour, so we can see that that makes sense. So that pattern is going to repeat. We'd have 10:20 all the way through, 11:20 all the way through. So let's think about the time that we've been given. We've been given 5:30 or 17:30. So we would have one at 17:20, and then we would have one at 17:35. So Paul will get on a bus at 17:35. Okay, so we've got some information about a hunger appeal, and we can see that £3 will buy 5 meals for one person. we've got to work out the cost of one meal. So what we need to do is take the total cost, divide it through by the 5 meals, and that will tell us what one meal costs. So 5s into 3 don't go. So we carry the 3, but there's nothing to carry it onto. When you reach a situation like that, you need to give it a 0. When you give it a 0, you need to remember to put that decimal point up in your answer. Now, 5s into 30 goes 6. And what we need to do is interpret our answer, that decimal of 0.6, in money, in pence. And that is 60 pence. We're now being told that £100 will buy lunches for 80 school children for 5 days. And we've got to work out the cost of buying lunch for one school child for 1 day. So the first thing we're going to do is take the total of £100, which buys these lunches for 5 days. If we divide it through by 5, that will give us the cost of just that 1 day. Now, remember, we're feeding 80 children. So we want to work out how much it is per person. So that £20 is going to get divided by 80. Now, there's a reason that I've written it in its fraction form, and you'll see why in just one sec. We would naturally go into our bus stop. So we've got to divide the 20 by 80. Well, I don't want to divide by a 2-digit. If I can avoid it, I absolutely will. And I can see that both of these numbers end in 0. So I could divide by 10 on both numbers. Really important that I do it to both numbers, and create 8 on the outside and 2 on the inside. And the reason it works is because it's following these kind of rules of equivalent fractions. 20 divided by 80 is exactly this. And I know that I'm allowed to divide through by 10 and cancel out a fraction. In fact, I could cancel it even further if I wanted to. But this is where we've chosen to stop. So 8s into 2 don't go. The 2 gets carried. Add your 0, put your point. 8s into 20 go 2, remainder 4, add your 0. 8s into 40 go 5. Now, we don't have units in this particular question. So I've got a choice. I can either say it's 25 pence, or I can say it's 0.25 pounds. And you are getting one of these 3 marks for using your units. Now, I have seen students write 0.25 pence. And if you do that, you will not get any marks, because what you've done is combine 2 different units into your answer. It's a bit like saying that something is 25 meters and then you're trying to say it's centimeters at the same time. You just can't really do that. So that would not be an okay answer. Okay, so we've got A, B, C, and D all on a straight line. We can see that the full length from A to D is 20, A to B is 8.6. We know that B, C, and C, D have the same distance, and we need to work out BC. So the first thing we really want to know is this distance here. And to do that, we're just going to simply take our 20 and take away 8.6. I say simply, we have to be really careful with our lining up. The decimal point is on the end of the 20, and it's really important that our decimals are aligned. So we're going to fill that space with a 0, and now we're going to reduce this down. So that's going to turn to 1, bring it across. That's going to go to 9, bring it across. 10 take 6 is 4, and then 9 take 8 is 1, and then we've got that 1. Decimal point still in its place, and we've got 11.4. Now, 11.4 is all the way across. But remember that BC and CD are equal in length, so all we need to do now is divide our 11.4 through by 2. So 2's into 1 don't go, carry the 1. 2's into 11 go 5, with 1 left over. Now, we have just hit the decimal, so it's important we put the decimal up at this point. And then 2's into 14 go 7 exactly. So our answer is 5.7 centimeters. Okay, so we've got a spinner, and our first question is asking us which number is the spinner least likely to land on. Well, the answer to that is 5 because there is only one 5 and there is more of the other numbers. From the following list of words, we've got to choose the one that best describes the likelihood of landing on a 2. Now, if we look at our spinner, we have got 3 sections that are 2. That's half the spinner, so the answer is evens. We've got to write down the probability that the spinner will land on 3. Looking at the spinner, 2 of the sections are labelled 3. So the chances or the probability of landing on a 3 is 2 out of the total that are there, which is 6. And 2 out of 6 is the right answer. If you were to cancel it to a third, that is obviously equally okay. Okay, so we are being asked to find out which one of these 2 places is going to enable us to buy the 25 plants we want as cheaply as possible. For Kirsty's plants, we need to do £2.39 times 25. There's no discounts, there's no promotions, it's just her flat rate, which means we need to do £2.39 times 25. Now, if you are good with this traditional method, you will just crack on and do it this way. But what I find is a lot of students will default to this method. Their brain is kind of trained to go there, but they haven't really gelled with it and they don't often get the answer right. So for that type of student, I strongly recommend retraining that brain to an alternative method. And I'm just going to have a link drop in on the screen now that shows you a video and walks you through the method really carefully. I have found, in my years of teaching, that students that move across to this do far, far better when they really haven't gelled with this one at all. So I'm not going to go through in great detail with this here, but I do have that video to help. So I'm going to be setting up my grid. That generally puts people off that haven't seen it before, but it's really simple once it's practiced. I put the numbers around its edges, and then I multiply in. And this is like a tens and units section. So 9 times 2 is 18. 3 times 2 is 6. I've got no tens. And I'm just going to keep multiplying in until I filled all the spaces. And now I'm just going to add through these diagonals. And I'll just highlight so that they can be seen really easily. So I've got 5 dropping out here. Here, I've got a total of 17. Put down the 7, carry the 1. I've then got 9. I've got 5. I can put down that a 0 would drop out here, but the 0 doesn't add anything to my number, so I don't really need it. So I've got 5, 9, 7, 5 that has dropped out. That's the answer to 239 times 25. Obviously, it was a decimal. The decimal was here. I needed to come in 2 places to put it back where it's supposed to be. So I just come in 2 places to finish my answer. So Kirsty's plants is 59.75. And this is a really useful and good way to do things, because sometimes our page can get really busy with its workings out and then we can lose key information. I have found the cost. I'm going to pop it up there, and then it's easy for me to see when I need to look at it again. So Hedge World, there's a pack of 25. It's £52.50 plus that at 20%. So I'm going to need to work out 20% of £52.50. To start the problem, I'm going to find 10%. 10% is always found by dividing by 10. So I'm going to move that decimal point 1 place, and I've got 5.25. That is 10%. I want 20%. So I need 2 lots of this, which is going to be 10, carry the 1, 5, £10.50. Now I've got to add that onto the cost of the pack, which is £52.50. And I'm just going to write it underneath. So I've got 0, 10, carry the 1, 3, and it's coming out at £63. So we can see the clear winner is Kirsty's plants. Okay, so we're going to use the conversion graph to change £5 to dollars. So just need to make sure I'm on the right axes on the right scale. So this is my pounds, there's my 5. Go up, hit the line, come across, and you can see that it is 8. So we can just write 8 straight there. It's a 1 marker. If that had been 2 marks, what we've just done would not be enough. And it would be really important that actually put the markings on the graph to show the examiner that I have read that graph properly. Now, Ella has $200 and £800. Her hotel bill is in dollars, 600. She pays the bill with the 200 and some of the pounds. We've got to use the conversion graph to work out how many pounds she has left. So the first thing to note is that her bill of 600 has the 200 paid against it. So there's an outstanding balance of $400. Now, I could come up and start choosing some different positions here, but we do actually already have this information, which is going to help us solve it. So we don't need to make much more work. We know that $8 is equal to £5. So let's work out how many $8 are in our 400. So we've got 400 to divide through by 8. 8s and 4 don't go, carry the 4. 8s into 40 go, 5 exactly. And then 8s into 0 go 0. So there are $58 in 400. So now we just need to times that through by our £5. 5 5s are 25, add the 0. Now we need to be careful. You might think you're done. Always reread that last bit here. It says use the conversion graph to work out how many pounds she has left. And it would be so tempting to put 250 on the line at this point. What we're going to have to do is finish this off. We had £800. We need to take £250 off. So we'll reduce that to 7, reduce that to 9, and we've got our 10. We don't need to do that. So to finish this off, we've got our 800 and we need to take 250 away. So 0 take 0 is 0. And now we just need to carry that 10 over. We've got 5. 7 take 2 is 5. And 550 would be our final answer. Okay, we've got toilet roll and we've got to work out which one gives us the better value for money. Now, in order to do this, we need to compare them. And there are different ways to do this. There isn't just one method. What I could do is I could try and find a number that they both go into. So, for example, 36. And then I could multiply it up to get a price for 36 toilet rolls in each situation. But honestly, I think the best way to approach any of these better value for money style questions is to just find the cost of one. So if 9 costs £4.23 and we want to know what 1 costs, we're going to take that cost of £4.23 and we're just going to divide it through by the 9. So as long as we are confident with our bus stop method, we will be good to go on this question. So 9s into 4 don't go. I'm hitting my point, so I'm going to put my point up and then my 4 I carry over onto the 2. 9s into 42 go 4 and we have remainder 6, and 9s into 63 go 7. So 1 toilet roll is 47p. And now we're just going to repeat the process on the other one. So we can see it's 49 pence for 1. So the 9-pack is better value. Okay, so we've got a crossover question here. Dylan is driving from London to Newcastle. He will drive a total distance of 240 miles. He's leaving at 9:30. And then we're given some information about that journey. So what we're going to do is we're going to build a picture of this before we do anything else. So I know that it's London to Newcastle. I know he's leaving at 9:30. It's a total distance of 240 miles. So I'll get that marked on. And it takes an hour and a half to do the first 90. So I'm going to say that in this section of my journey, the distance is 90 and the time is 1.5. I've changed that 1.5 into decimals. I also know the distance here. 240 take away 90 is 150. So I can add that into my diagram as well, because I do know that. Now we've got to use this information to estimate the time Dylan will arrive in Newcastle. Now, in order to work out the time, we're going to need the speed and the distance. Okay, these are our keywords, and we've got this formula triangle to help us. I'm going to need the total distance and the speed. So in the first part of the journey, the speed can be found because we've got both D and T. So 90 divided by 1.5. Now I can go into bus shelter, or I can actually think about this. If I've got 90 minutes taking 1.5 hours, if I divide this through by 3, that will give me 30 minutes. And if I was to divide this through by 3, it would give me half an hour. I've got 3 half hours in an hour and a half. So I can then see that it's 60 minutes in 1 hour. And that may be a better way than going straight into your bus shelter. But of course, your bus stop's going to work as well. So it's just a couple of ideas really of how you can get to your speed of 60 miles per hour in that section of the journey. Now, we are assuming he's driving at the same speed throughout his entire journey. Now we know that the speed is 60. I can work out the time it's going to take to travel that distance of 150. So we've got 150 over 60, distance over time. Sorry, distance over speed. Divide through by 10. I can then divide through by 3 to cancel this down a little bit. 3s into 15 go 5, 3s into 6 go 2. How many 2s can I get into 5? 2 with 1 left over. So that second part of the journey is going to take 2.5 hours. The first part took 1.5 hours. If I add those, I've got a total time of 4 hours. So you add your 40 and 9:30, so 10, 11, 12, that'll be 1:30, and that is your final answer. We have to write down an assumption that we made, and we assumed the speed was the same throughout, and that's what we would write down. Another factor that we could have considered and written down to get that mark is that I assumed there would be no stops along the way. That would be an acceptable answer as well. Okay, so we're being asked to describe fully the single transformation that maps P to Q. Now, transformations is a big topic. It contains translations, reflections, rotations, and enlargements. So this is a bit of an elimination process that we go through in order to try and find the right one. Now, a translation slides a shape around. So it would slide the shape forwards or backwards, up or down. But when it finished, it would still look exactly like this. And this most certainly does not. So you can eliminate that. It hasn't been made bigger or smaller, so you can eliminate that. So really, we're looking at whether this is a rotation or a reflection. Now, a rotation twists. And if we imagine this twisting around, it would change and possibly take this shape. But it's very difficult to visualize. So this is where the magic of the tracing paper that you are allowed in your exam, you will be given in your exam, comes into its own. It's fantastic here. What you would do is you would place it over the shape that you have been given. You would trace the shape. And the more accurately you can trace over the top, the better, because it's going to help you see exactly where the new shape is going to go. Now, what we have to do next is stab using our pencil. So I'm going to use my red dot as my sort of stab. I'm going to start by stabbing at the origin. What that's doing is it's pinning the tracing paper to a point, and it will enable me to twist it, which unfortunately I can't show due to the software. But what you would do is you would pin it in place and twist it. If it landed exactly on top, you know that you have pinned it in the right point. If it's slightly over, slightly under, you know you have to find a different point. And then you would start working your way around all the different points of the origin. If they didn't work, keep going until you find the right point. So stab, twist. If it sits on top, bingo, you have found it. And in this case, it actually does. So it's just a case now of getting it written down clearly as to how you describe it. So we know it's a rotation. It's a quarter turn around the point or center, 0, 0. You could say about the origin because it is the origin. Now, this here is not good enough. It is a quarter turn, but the quarter turn could go in that direction or that direction. So it's really important that we are clear that it is clockwise to get that mark that's linked to that part of the answer. Okay, so we've got another crossover question. So the diagram shows the cross section of a solid prism. Now, when we're reading that word prism, we should be realizing that what we're actually looking at is a 3D shape. They just haven't drawn a 3D shape. They've just done the cross section, which would be the front face. The length of the prism is 2 meters. Now, again, if we look at the diagram we've been given, all the edges on the cross section are in centimeters. So we really kind of need to clock that as quickly as possible. I'm going to draw on that length just so I can visually see it, and I can then be mindful of my shape because I can see the whole shape. And of course, this edge here is 200 centimeters. I want to stay in the same unit, so I'm converting my 2 meters to 200 centimeters. So just in those first 2 lines, I've been able to glean all that information and get it added into that diagram. The prism is made from metal. The density of the metal is 8 grams per centimeter cubed. I've got to work out the mass. Now, those are those key words that I want to be picking up on. We've got our formula triangle, mass, density, volume to help us. The density has been given to us. So we've got that. We have to work out the mass. We can't do that unless we have the volume. And the volume has not been given to us. We know that the units of the volume have got to be centimeters cubed because they're telling us that in the units of the density. So having changed into my centimeters, I've already kind of set that up in motion. And now I've really just got to work out the volume. So we're going to split this cross section and we're going to work out the area of the cross section. So we've got this section here, which is 7 by 2. And then we've got this section, which if this bit here is 2, then that's going to be 5. So it's going to be 5 times 2, which is 10. So my cross section is 24. I'm going to times that through by the length, which is 200. That's going to give me 4,800. That's my volume. Mass is density times volume. So I've now got to do 8 times 4,800. Again, it's really down to you. When I'm multiplying by 1 digit, I tend to just break the whole thing up. So I would say I've got 4,000 times 8, and I would say I've got 800 times 8. So 4 8s are 32, and then I've got those 3 zeros. 8 8s are 64, and I've got 2 zeros. Just be careful when it comes to lining that up. And my final answer is 38,400. Now, if you look at the dotted line, and I'll just pop down there so that you can see, if you've not got the paper in front of you, there are no units. So it's absolutely essential that we include the units or we're going to lose a mark. The units are with the density here. And I'll explain how that works in case you're not sure how I just know this. Okay. So I know it's grams, and that's my final answer. Now, if I go back to my formula triangle where I've got mass, density, and volume, mass is grams, volume, that looks like a Y, is centimeters cubed, and the density is these two on top of each other, grams over centimeters. It's a bit like miles per hours. Your speed is your distance over time. That's your units. Hope that gave some clarification. Okay, so on the grid, we're being asked to draw the graph of y equals 3x plus 5 for the values of x from -2 to 3. So my y coordinate equals 3 times whatever the x coordinate is plus 5. I've got to do it for the values of -2 to 3. Now I'm going to start with the positive rather than the negative, because positive numbers are easier to work with. So I'm replacing the x with the coordinate 3. And 3 times 3 is 9 plus 5 is 14. So I know that my first coordinate when x is 3, y is 14, and I can pop that on. And then I'm just going to repeat the process. When x is 2, I'll have 3 times 2 plus 5, which is 11, and then I can plot that on. 3 times 1 plus 5, that's 8. So 1 and 8. Now, what I might be able to do as I've been plotting is start to spot a pattern. I've got to create a straight line, and I can see that straight line is coming. I can see that I went down 3 in a long one. I went down 3 in a long one. If I keep that pattern going, I can put the rest of the coordinates on without actually having to work all the calculations out. So down 3 a long one, down 3 a long one, down 3 a long one. And if I was to accidentally misplace one, it would be really obvious because it wouldn't lie on the line. The last job is to just draw a line through those points. Now we've got to explain why the point 6, 24 does not lie on the line y equals 3x plus 5. Now, if we look at the graph, it doesn't really help us. The x coordinate doesn't go up to 6, so I can't see what's happening up here. So instead, I'm going to have to use algebra to help me solve this. Never forget that your coordinates are x and y, and in the equation y equals 3x plus 5, the x and the y are your coordinates. We used that fact up here when we were trying to find the coordinates in the first place, and we're going to use it again in this part of the question. Y is going to equal 24 when x is 6 if it lies on the line. So let's test it. 3 times 6 plus 5 is equal to 23. So when x equals 6, y equals 23. And that's us showing it does not lie on the line. It can't lie on the line because the coordinate 24 does not work when x is 6. Okay, so Ramesh throws a biased coin. The probability that the coin will land on a head is 0.37, and we've got to work out the probability it will land on a tail. Now, the two things are a certainty, so together they add up to 1, and we use that to help us solve the question. 1 take away 0.37 is 0.63, and that's the probability of getting the tail. It's going to throw the coin 500 times, and we've got to work out an estimate for the number of times it will land on head. So the probability for head was 0.37, and we multiply that to the 500. So again, we're going to have to work out how we're going to approach this problem. Now, I will completely ignore the decimal and call it 37 for now. I'm actually going to ignore the 2 zeros and call it 5 for now. And I'm going to sort the whole thing out when I have finished. Breaking it up into 30 times 5, which is 150, 7 times 5, which is 35, and they add to 185. But of course, I shouldn't have been multiplying just by 5. It should have been by 500. So if I want to correct that, I'll times that through, and then that's going to give me 18500. Now that is the answer to 37 times 500, but this was a decimal, not a whole number. I'm going to need to come in 2 places to get the decimal in the right place. So 2 places, it basically cancels out the 100 I've just put in. So it comes out at 185. Okay, so we've got a car that's being bought for 4,000. It's depreciating by 10% each year, and we have to work out the value of the car. Now, if you're one of my students, I will have drummed it into you to do a 2-tick test, which this passes because this is a decrease, and we would be doing original times multiplier equals result. We have a period of time, so the multiplier has that time attached to it as a power. But this really is a calculator method, and we need to remember that. It would work, but we'd be doing a lot of maths by hand. So we really need to think about our non-calc methods. It's depreciating by 10%. Now, if I find 10%, all I have to do is divide by 10. So it's very straightforward to get started on this without overcomplicating it. So it's going to lose £400 in its first year. So 4,000 take away 400 is 3,600. However, we don't use 400 again because the value of the car is now 3,600. In the second year, it's going to be 10% of that. So dividing that through by 10, we've got 360, and that's what we're going to take off. So we'll just reduce that, carry that across, gives us 4, 2, and 3. So our final answer is 3,240. Okay, another crossover question. We need to write these numbers in order of size. Now, to do that, I'm going to express them all as ordinary numbers first of all. So the first one, if I am going to be timesing through by 10 to the 2, it's the same as timesing by 100, or moving that decimal point 2 places, which would give me 3.8 as an ordinary number. Timesing by 10 to the minus 2, remember a negative power is going to make it smaller by 4 movements. 1, 2, 3, 4. This is 0.3800, or just 0.38. You can add them in or not, entirely up to you. I probably wouldn't normally. And then we've got a negative 1, so just one place will give us that ordinary number. Once I've got the ordinary numbers, it's easy for me to then start seeing them and comparing them. So 0.0038 is the smallest. So I would be writing that one down first. This is the next smallest, and finally 380 on the end. And notice I'm using the numbers that were originally given to me when I do rewrite them. Okay, another crossover question. And the last one, if you are on the foundation paper. There are 18 packets of sweets and 12 boxes of sweets in a carton. The mean number of sweets in all the 30 packets and boxes is 14. And then we've got more information about the mean on just the packets. And we want to work out the mean in the boxes. So we got to break this down line by line. We know that the mean is add them all up and divide by how many are there. So that the meaning of the word mean doesn't change. This context is very different now because we don't have a list of numbers to add. What we do know, however, in this first line is that the mean of all 30, so that's how many are there, is 14. So there's this total that got added together, and when it got divided by 30, it gave a result of 14. What that enables me to do is to get the total. If I just bring that 30 across and multiply by it, so 3 14s are 42, add the 0, then although I don't know all the individual numbers, what I do know is that all 30 of them will add to that. And then I'm going to do the exact same thing with the mean for the packets. So I know that there is a total of 18 packets that when it's added together, there's this value. I don't know what it is, but there's this total. But if I was to divide it by the 18, it would equal this mean of 10. And again, if I just multiply that through, I can see that the total for the packets is 180. Having these two totals is going to help me with getting the mean for the sweets, because again, I'm going to need the total of the sweets to divide by how many sweets there are. Well, I do know that number, it's 12. That's in the first line. That's going to equal the mean, which is what they want me to find. So this bit here needs to be found using what we've got so far. And we've got the total of everything together, and we've got the packets here. So 420, take away the 180, is going to leave us the boxes. So that would be 0, that would be 4, that would be 2. So it's 240. So we're doing 240 divided by 12, which is really nice and straightforward. 12 into 24 go 2, add on the 0. So our mean is 20. Okay, that's it. Well done. They are hard. I hope you're finding the work solutions useful. You are doing what you need to be doing, and that's showing up and giving it a good go. So if it's not going as well as you like, just get that kind of determination cap in place and really just keep going. I promise you, the more you do, the easier it will start to become. And you'll also start noticing how some of these questions feel familiar from paper to paper. So do join us for more. We're going to be dropping these papers into the playlist regularly, and hope they really do help with your revision. If they are, please like and subscribe. It really helps me, and it helps other people find the channel, which is always good.